So, zero and negative exponent rules. So if you remember what we've been talking about, anything raised to the 0 power, so if we have 5 to the 0 times, or not times, sorry, wait just a second. So if I have something to the 0 power, that means I have 0 5s. So they're pretty much just canceling out. So I could cancel out the 5 to the 0, but remember, it's not 0. When things cancel out like that, we're left with a 1. So it would be 5 to the 0 times 1, or our answer would just be 1. So 5 to the 0, remember we've been talking about it. Anything raised to the 0 power just cancels. There's nothing there. Even if it was 205. 205 raised to the 0 power means you have 200, you don't have 205. So I always think about it as money. If I told you I had $1 million raised to the 0 power, I really don't have $1 million. I would just have the 1, okay? Now, if we look at this one, 4a to the 0. So we have 4a to the 0. Now, remember, when we have a number and a variable like that, it's actually it's actually multiplication. So it's 4 times a to the 0. And notice there are no parentheses. I'm going to use a pencil real quick so that I can erase it. So there are no parentheses here saying to the 0 power, just like in this one. See how all of this information is inside the parentheses raised to the 0 power? This one is not. So the only thing that actually has the 0 power, oops, my pen wasn't dry yet. The only thing that has a 0 power is this a to the 1, or a to the 0. So that's what cancels out. Remember, when it cancels out, it becomes a 1. So 4 times 1 would give us an answer of 4. Okay, now here's the one that I'm talking about, where it's parentheses 2xy to the 0. So all of that, 2xy to the 0, all of that's raised to the 0 power. So all of that would cancel. Even if inside of there was 400, x, y, z, a, q, p, all of that stuff, anything raised to the 0 power, like I keep saying, is 1. So the answer here is just 1. So those are all the 0 exponent rules. Now let's start looking at negatives again. So if you look at 9 to the negative 2, remember, I'll rewrite it just so that I can show things. So 9 to the negative 2, remember, to get rid of the negative, you have to write it in the bottom. So think about this as over 1, and now we need to flip it, and the 9 to the negative 2 needs to be in the denominator. So it would be 9 squared. And remember, the negative goes away when I do that. So you could draw an arrow here. Okay, so 9 to the negative 2 becomes 9 squared, and then that's just our answer. We're not actually multiplying these things out, we're just simplifying it. So 1 divided by 9 squared. If you wanted to multiply this out, 9 squared would be 81, so it'd be 1 divided by 81. Okay, now look at this one. This one we have a negative exponent, but it's in the denominator already. So again, same thing. So 1 over 4 to the negative 2. If you look at this one, notice that over 1, because 9 squared divided by 1, anything divided by 1 is just the same thing. So we ended up flipping this. So now we have a 1 on top with a 4 to the negative 2nd on bottom. Well, if it's on bottom, you're going to move it to the top. And then again, we have to have that placeholder of 1. So notice the entire fraction flips. Or the stuff with the negative exponent flips. So then our answer here, remember, would be 4 squared. We do not have to write a divided by 1. So our answer would just be 4 squared. Okay. Now let's get into some variables. So I have m to the negative 6, or negative 4, divided by m to the 6th. So when you have a negative exponent, remember if it was by itself, that information moves to the bottom. Well, this m to the negative 4th is what has a negative exponent, so that needs to move to the bottom. Well, there's already an m to the 6th down there. So I would definitely suggest, so you already have an m to the 6th. That's down there. It didn't have a negative, so I wouldn't flip it to the top. It would just need to stay there. But the m to the negative 4th had a negative exponent, so now we need to write it as m to the 4th. And then there's nothing on top, but remember we have to show that it's on the bottom, or that that is in a fraction. So remember that placeholder of 1. That 1 is just a placeholder to show that this information is in the denominator. Okay? Now let's go ahead and expand it out. So we have 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3, 4. So I have 6 plus 4, which is m to the 10th. Or if you count them all expanded out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be our answer. Okay. Now if we have x to the negative 2y cubed, so notice the only thing that has a negative exponent, I'm going to circle it. So that's the only thing that has a negative exponent. So it might help in some cases, and you can keep doing it that way if you want. If I put this over 1 and I say this has a negative exponent, I'm going to mark it out and I'm going to write it down here in the denominator. So then it would be y cubed and this x squared moved to the bottom. That will probably help you if you actually mark it out and then write it in the bottom, in the denominator. Whenever you start having more things like this one down here, it will help you keep track if you just mark out the one thing that's moving. So here I could have marked that out and then just written it down here. There are no y's to combine with or cancel with from the bottom. There are no x's on top and bottom. So your answer would just be y cubed divided by x squared. Okay, almost done, have 2 more. All right, so now we have 5x to the negative 2. So just like I was saying up here, remember when you have a number and a variable right in front of each other, it's like they're, or it's not like, I keep saying that, they're multiplying. It's an implied multiplication. So the 5 does not have the negative exponent. The x has the negative exponent. So I'm going to write it as a fraction, mark out what has the negative exponent, and write it in the denominator. So it would be 5 divided by x squared. So then my answer would be 5 over x squared. There's no numbers or anything like that. Okay. The next one, we have 4xy, 8x cubed. So if we have 4 over 8, if I have 4 eighths, remember you can reduce this because, so if you think about $4 broken between 8 people, so $4 broken between 8 people, each person would get half of $1. I always think of it as 4 goes into both of those. 4 goes into 4 one time. 4 goes into 8 twice. So it'd be 1/2. So don't forget, just like we cancel variables, you could also write this 4 as 2 times 2. You could also write that 8 as 2 times 2 is 4 times 2 is 8. Just like we were doing whenever we were talking about square roots and cube roots. You can write that 4 as 2 times 2. You can write the 8 as 2 times 2, which is 4, times 2, which is 8. 2's cancel, so you're left with 2 on the bottom, and you have a placeholder of 1. I personally like to think of it as 4 goes into 4 one time, 4 goes into 8 twice. So it'd be 1/2. We have x, y, then we have x cubed, so 1, 2, 3. I can cancel a set of x's, so I would be left with 1y, 2x, x. We don't have to write the 1 because it's 1 times y, which is just y, and then it would be 2. X times x would be x squared. So that is your zeros and negative exponent rules.